science. We are going to watch a video about our ear. You could get beyond the...
How are you listening to this music right now? Well, you might know that your speakers are creating sound and your ears are listening to it. But there's a lot more going on over here. You see, all your speakers are doing right now is vibrating the particles of the air close to it. Then they vibrate the air molecules close to them, and so on and so forth. And we call this a sound wave. And eventually, when the air molecules close to your ears start vibrating, we hear sound. But how does something as boring as air molecules going back and forth make us experience something like this? Well, for that, we need to look at our ear carefully. I mean the entire structure of the ear.
So here's the outer ear.
So let's look at how the different parts of the ear work together to make us experience sound. So our ear can be divided into three parts: the outer ear, the middle ear, and the inner ear. The outer ear starts with the pinna. It's the part that you can see and touch, or in my case, the part that my mom would twist quite often. Its job is to collect as much sound waves as possible and channel it into the auditory canal. The sound waves pass through the auditory canal and eventually meet the eardrum, which is shown in green over here. The eardrum is a transparent membrane which is super sensitive to the vibrations of the air. So as the air vibrates, even the eardrum starts vibrating, just like the skin of a drum. And as you can see, the eardrum also separates the outer ear from the middle ear. This brings us to the middle ear. The middle ear consists of the three tiniest bones of the human body, and they're together called the ossicles. And they have pretty cool names. They're called the malleus, the incus, and stapes. And here's the actual picture of these three bones. And because of their shapes, they're also commonly called as the hammer, the anvil, and the stirrup. Stirrup is where you rest your feet when you're riding your horse. Alright, so as the eardrum vibrates, you can see the ossicles also start vibrating, transferring the vibrations from the eardrums to the inner ear. Now their main job is to increase or amplify the pressure of the sound waves when it reaches the inner ear. But why do we need to increase the pressure of the sound waves? Because as we will see, the inner ear consists of a liquid, not air. So the vibrations must transfer into a liquid. And you might already know that vibrating or moving particles of liquid is much harder than moving particles of air, which is why it's very easy for you to swing your arms in the air, but it's pretty difficult to do that inside water, like say in a swimming pool. And so to set this liquid in vibration, the pressure has to be high enough. And in fact, it turns out that our ossicles increase the pressure of the sound about 20 times. But how do they do that? Well, just take a look at the base of the stapes. It has such a small area compared to that of the eardrum. So when the force gets transmitted from the eardrum to the stapes, it gets concentrated in a very tiny area. And you might know when you concentrate force in a very tiny area, you increase its pressure. And that brings us to the inner ear. The inner ear consists of a bony structure, which is shown in purple. Now, as you can see, the top part of this structure consists of three semicircular rings. They help us in maintaining our balance while walking or dancing or whatever we do. So they're not involved in hearing, so not so important for us. The part that's involved in hearing is this snail-like structure. This is called the cochlea. What does it do? Well, although these bones have already started dancing to the music, nothing gets heard until these vibrations are converted to electricity and sent to our brain. And that's exactly what the cochlea does. Now, the cochlea is super complex, and it's also a little mysterious. Even today, there are certain things about it we just don't know. And so, we'll definitely not go into the details. But as mentioned earlier, it contains a liquid. And when the stirrup hits our cochlea, this liquid starts vibrating. And then there are some specialized cells in the cochlea that convert these vibrations into electrical signals. And these electrical signals go through the auditory nerves all the way to your brain, where it gets finally interpreted as sound. And the cells of your cochlea are amazing. The electrical impulses that they generate are super sensitive to how loud the sound is or how feeble the sound is, whether it is high frequency or low frequency. And as a result, your brain can differentiate the tiniest differences in the sound. And so you can understand different letters or words, or even understand what I'm saying right now, or hear the different notes of this music. And so, to summarize, the outer ear collects the sound waves through the pinna and directs them to the eardrums. The three optical bones of the middle ear amplify these sound waves, transferring it into the cochlea, and the cochlea converts the back and forth vibrations of the particles into electrical signals and sends it to our brain. And regardless of how many words I use to describe what's going on, the very fact that the back and forth movement of the air can be converted into this amazing experience we call sound is truly unfathomable and beyond words.
So, the ear is pretty amazing. There is a lot going on. This very second, for you to hear me talking, all of that is occurring within the ear. Yeah, it's amazing. So God created quite an amazing structure when he did the ears. That all of those things have to simultaneously occur in order for us to hear. So, we are going to do a little comprehension worksheet for you to further understand. We'll do it together. I want you, as soon as you get it, and my virtual friends, I will send this in your packet. So he went over a lot of these names, and Jonathan has his little, I would do that too. I would open your textbook to 119. There is a diagram of your ear. It's helpful to see it while you're learning about it. Then you can visualize where these are in your ear. Yes. How do you do that? Jeremiah can move his ears. How in the world? You're not moving anything out there? how the function happens. So there you go.
Wait,
Not
let me show
119 in your textbook
Okay, that's cool.
will help you visualize what you're reading.
Can you do that again?
All those little teeny tiny bones inside our ear. It's freaking crazy. Yeah. Oh. Yeah, the ears is too crazy. All right, so who wants to read about the pinna? The first paragraph, parts of the ear. Ella. Shh, okay, hold on. Hey, you're talking. There should be no talking. That's very rude. Okay, Ella, go ahead. Ted, talk loud.
The peanut is part of the ear that you can see. It's the part of your outer ear that you can. It can be also known as
The auricle.
article.
Auricle.
Article. The peanut collects sound
And funnels.
and funnels them into your ear canal.
Everybody point to your pinna of the ear. He was saying that that's what his mother used to grab and twist. So if somebody ever grabs you by the ear, they're grabbing you by the pinna. P-I-N-N-A. That is your outer ear. That is part of the ear that we see. Okay? Who wants to read about the ear canal? Jack.
The ear canal is a part of the outer ear. This part of the ear is like a long tube that the sound travels through the ear canal.
Canal.
Canal produces wax that helps to keep your ears clean from germs. The sound travels through the ear canal
Canal.
to go to the middle ear.
All right, so, and your diagram in your textbook. Okay, where's mine? Huh. There is a tube. You see the tube that is going from the pinna to the middle ear. There is a long tube. Open up your book to 119, please. This tube, as you can see, the sound waves are going through. Here is the pinna. Here is the eardrum is here, and here is your canal, the ear canal. That long tube is what the waves travel to get to the middle ear. Let me turn this off. That kind of so bright.
But it looks so more pretty. With it.
So, can you visualize that so far?
Yeah.
Now, the ear canal. Okay, so let's go to the eardrum and then I will discuss. Okay, so the eardrum. Who wants to read that? Gabe. Or Christian, sorry.
The eardrum is a thin piece of the skin that you can stretch.
This piece of skin that is stretched. We don't stretch it. You don't want to stretch your eardrum. That would not be good.
That'll be.
Be really bad. Okay, go ahead.
The sound hits the eardrum and vibrates. Your eardrum is very soft and fragile, so you should never touch or stick anything in your ear.
Yes. It looks like that, your diagram looks like it's a long, long tunnel that goes from your pinna to your eardrum. It is not that long of a tunnel. It doesn't take a lot to damage your eardrum. So do not stick anything in your ear. That is not a good idea. If you hear of babies wedge things in their ear, then they have to go to the doctor because you're going to damage it trying to get it out. Yes. So we're going to learn about the three bones of the ear, the ocelles, the eardrum vibrating. Who wants to read this? Talk loud, please.
The eardrum vibrating with the three bones of the ear or ossicles. Three bones in the ear are called
The malleus,
malleus,
the incus,
incus,
and the steeples. Steeples. It's, yeah.
These bones are the smallest bones in your entire body. They can also be called the hammer, anvil, and stirrup. When these tiny bones vibrate, the sound moves along to the inner ear.
So do you remember when I hit the object, the metal on the metal, and you heard the vibration? So that is basically what these three bones do. They create the vibration. The waves go in, the vibration occurs, and then it enters into a different area. But you need to remember when you heard that, that is what is occurring inside. How do we hear? The sound waves go in. How do we hear the sound waves? What must occur for us to actually hear and determine what the sound is?
The object has to be vibrating.
Yes. It's not the sound wave. It's the vibration that causes us to register and understand what we're hearing. So that is the purpose of these three bones. The hammer, the anvil, and the stirrup. Our smallest bones in our body help us to hear. Isn't that amazing? They do a mighty job. If you plug your ears, can you hear me talking?
Yes.
It's very hard to plug your ears, please. If you plug your ears, you are blocking the sound waves. Can you hear me somewhat?
Kind of.
Now unplug your ears. So now you can hear me. Why do you think when you plug your ears, what is happening? What is happening to create us not to hear? Jonathan.
The sound waves aren't getting inside the ear.
Bingo. If the sound waves cannot get in, so all the sound waves, remember the sound waves go everywhere. They go into our ear, into the three little teeny tiny bones that cause the vibration. Therefore, we can determine what we're hearing. Is that pretty amazing?
Yeah.
No? I think it's pretty amazing that the smallest bones in our body help us to hear. All right, God is pretty amazing. Now, let's read the next part. The cochlea. The sound that enters the cochlea. Who wants to read that? Winsheen. Talk loud, please. Loud and proud.
The sound that enters the
Cochlea. Very good. So on your diagram, do you see what looks like a snail?
What?
Yeah, we're in the inner ear now. So you see that is the cochlea, that little snail-like object that was in, that is what we're talking about now. You all see it on your diagram?
Yep. Yeah.
So then, the little musical notes.
It's like
So it goes in as a sound wave. It goes through the whole process, through the canal, through the middle ear, the inner ear, and then it comes out as a musical note. Why is it coming out as a musical note and not going in as a musical note? Why aren't the musical notes going into the ear? Jack.
I actually have a question.
Well, I want just a minute. Questions can come after. Why is it? Because this is key for you to understand what the function is what's going on with this function of our ear. Why is it not? You see, the musical notes are going out of the inner ear into the brain. That's the key word there, the brain. It's going in as a wave and going out as a musical note. Christian.
I think because the sound waves are traveling the notes, and the sound waves are carrying the note, and then they stop, and then they let go of the musical notes.
Kind of. You're kind of along the right lane. What? Okay, Toby, let me answer. Have you guys try to before I give you the answer. Yes, Toby. Yes. Tyson.
Because all the parts are used to get sounds to your brain. It would be the same way if your brain was right here. The opposite. All of the sound would be going here. So all the sound goes here, and that if it goes here, it would be the opposite.
You're on the right track. You're on the right track. So it goes in as sound waves because our brain does not know what it is yet. So it goes in our ear as a wave. It goes through all of the parts, and then once it goes through the cochlea, it knows what it is. Oh, I'm listening to music. But it has to register with the brain before we understand what it is. That's how fast this all works. I mean, we're talking extremely fast. So, when you plug your ears, the sound waves cannot get in. So you can't hear because your brain can't register what it's hearing. It's not hearing anything. That's why if somebody cannot hear, if they are deaf, their brain is not registering sound. In order for our brain to register the sound, it has to go through the parts of the ear. And then it knows, oh, this is Mrs. Reed talking. Oh, this is music. Someone's screaming. There's an alarm going off. A baby's crying. A cat is meowing. A dog is barking. But that all the parts of the ear have got to occur in order for the brain to register. In as sound waves and out of the inner ear as what we are hearing. So you are sitting here listening to me talk. And you're hearing what I'm saying right away, right? Now if I turn on, sit down please. Music. Turn it off. That's how fast it is. That's how fast so these are all parts. So let's work on the rest of this, and we're gosh, our day is almost done, friends. So what are the three sections of the ear? We are on the first page, all about. Owen. Right, what is first? Yes, then what? Yep, then what? Yes. So write those three down. What is the part of the ear that we can see? Who remembers what that is? Ella. The pinna. That's right. Number B. Circle number B. What is the function of the pinna? Luke. What's that? No. What is the function of the pinna? Cole.
Almost on to the middle
Okay, we're on page 3, on this page where it's on all about parts of the ear. Funnel sound to the middle ear, change sound to nerve signals, produce wax to clean the ear. What is the function of the pinna? Jonathan.
Produce wax to clean the ear.
Okay, remember your diagram. What is the first thing that we get? What is coming in our outer ear? The sound waves, remember? So the sound waves goes through the pinna to our canal. So the answer is it funnels sound to the middle ear. Look at your diagram, those little waves. Those are going from out here through the pinna to the middle ear. What is the name of the part of the ear that separates the outer from the middle ear? Boy. No. Oh, I was looking at the wrong one. No, remember cochlea is the very last stage. That is in the inner ear.
It's a snail thing.
What's that?
It's a snail thing.
That is the cochlea is the snail. So that is the inner ear. If you think of that, look at the snail as the last part of the whole function. So we're going in the canal. What is the next thing that the sound wave reaches that we have to be really careful of? Christian.
Eardrum.
Yes. What does the eardrum have to do in order to signal the bones of the ear to move? How do we register sound? What has to occur for us to even hear sound? The waves come in, but can't hear the waves until what occurs? Emmy. Yes, the vibration. Vibration is key, friends. We are not going to hear anything until we get the vibrations. And remember that that video showed how the whole bone structure moves. It's like dancing to the waves. There's a lot of movement going on. Right, Tyson? All right, let's finish this up because are you writing this stuff down so you can have this and study it? List the names of the 3 bones in the ear. Now remember, these answers are all on your sheet in front too. We just read it. What are the 3 bones? You're going to want to, you could call it the hammer, the anvil, and the stirrup because the other words are kind of hard to pronounce. The malleus, the incus, and the steeples. Or the hammer, the anvil, and the stirrup. It's in this paragraph right here. Jonathan.
What is this big
That is,
thing?
oh, that's just part of the ear. I mean, that's like a vein or something that's going out of the ear. That's not any part of the ear that we need to worry about. All right, so, because there's lots of, our human body are full of veins and muscles and all these capillaries and so forth that, yeah, that's what that is. All right, what is the name of this snail-shaped tube that changes vibrations to nerve signals? Signals. We talked about this. It's kind of a fun word to say. Helen. Yes, the cochlea. Number C. I mean letter C, number C.
What page are we on?
So, the little hairs. What do? You envision these little hairs in on the cochlea. They're little hairs. What do? Christian.
They understand what the sound means.
Where are you getting this? We're number 9. I mean, yeah, the 8. They understand what sound means? No. What is the purpose of the cochlea? Remember, it changes the waves, the vibrations into what? And it goes right to the brain. Jack.
A?
Yes, they change the sound to nerve signals, and that goes to the brain. Then the brain it signals to us what it is we're hearing. Oh, that's a dog, or that's Mrs. Reed talking again. When sound travels through the auditory nerve to the brain, what happens? When it finally gets to the brain, what happens? Cole?
The brain uses the nerve signals to understand
Yes,
what's happening.
that is correct. All of that has to occur before we understand what we're listening to. Pretty amazing. All right, so again, my friends in virtual land, I will get you this. I know you're at a disadvantage, but I have these in your folders and you can go through it. It's just a nice little study on the ear.
I have a question.
Yes,
What about the last part?
the drawing, you can do that on your own.
I don't really know what it is.
Just draw the path the sound takes to the brain. All right, well, your diagram also shows it. The right waves come from where? Where do the waves come from? Everywhere. They're everywhere. And then they go through the what? So you can draw your little waves. It's like on your diagram. They go through the canal. And then they work through the anvil and the stirrup, the hammer, the anvil, and the stirrup. And then they go through the cochleus and then out of the cochleus to the auditory nerve and to the brain. So it follows that whole path like on your diagram. And then you can see that there's that picture, which is interesting, of our brain. In our ears, we have two ears, which means we have sound waves and we have all this occurring simultaneously with two ears. So all of those waves are going into our ears at the same time. The brain has got to work fast, doesn't it?
Yep.
Yes. Pretty awesome.
Are the three Chinese bones in our body hollow?
Are they hollow?
Yeah.
No, they're bones. Bones are not hollow.
They are hard.
They're very hard. Yes, Grayson.
I have a comment.
Yes.
Birds' bones are hollow.
Yes, they are. Birds'
Oh, yeah.
bones are hollow,
So they can fly.
so they can fly. Because what would happen if birds had solid bones?
They would
Be very hard for them to what?
fly. They would just fall. No.
They'd be penguins. That's right.
They're too heavy.
So they'd be too heavy. That's correct. Yes, Olivia.
Do turkeys have hollow bones?
Well, they're birds. I think so. I guess I don't.
They can fly.
They can fly. They're not the most graceful of flyers, but they can fly. I've seen turkeys take off flying, and I'm thinking that bird cannot fly well. He is going to hit a tree or something else. All right, any other questions concerning our ear? Yes. Winsheen.
So the bird's bone is really like inside of it is something that is looks like this, like that. Inside of the bird's bone.
Oh. If they can fly? Yeah, they are much lighter, so they can fly. But they do have bones, but they're much different than our bones, because we don't fly. All right.